Question 1. A solutions architect is designing a data lake solution in Amazon S3 to protect against accidental deletions and unintended overwrites of critical data objects. Which S3 feature should be enabled on the bucket? Option A, S3 lifecycle policies. Option B, S3 versioning. Option C, S3 cross-region replication, CRR. Option D, S3 object lock. The correct answer is S3 versioning. Here's the explanation. S3 versioning is specifically designed to keep multiple versions of an object in the same bucket, acting as a safety net against accidental deletions and overwrites by storing a new version rather than permanently removing or replacing the old one. This allows for easy recovery to any prior state. Question 2. For Amazon S3 replication, CRR or SRR, to function correctly, what is a mandatory prerequisite for both the source and destination buckets? Option A. Both buckets must have S3 object lock enabled. Option B. Both buckets must be encrypted with AWS Key Management Service, KMS. Option C. Both buckets must have S3 versioning enabled. Option D. Both buckets must have a lifecycle policy configured to move objects to Glacier. The correct answer is both buckets must have S3 versioning enabled. Here's the explanation. The study material explicitly states that for S3 replication, both CRR and SRR, to work, versioning must be enabled on both the source and destination buckets. This is a fundamental requirement for replication to track object changes and versions. Question 3. An administrator wants to ensure that critical compliance archives stored in an S3 bucket cannot be permanently deleted by a single user, even if they have root credentials, without an additional layer of security. Which S3 versioning-related feature should be enabled? Option A, S3 Replication Time Control, RTC. Option B, S3 Transfer Acceleration. Option C, S3 Object Lock in Governance Mode. Option D, MFA Delete. The correct answer is MFA Delete. Here's the explanation. MFA Delete is an optional security feature associated with S3 versioning that requires multi-factor authentication for permanent deletion of an object version or changing the versioning state of a bucket, providing an extra layer of protection against unintended or malicious deletions. S3 Object Lock provides immutability, but MFA Delete specifically addresses the multi-factor authentication requirement for permanent deletion. Question 4. An S3 bucket policy is configured to explicitly allow public read access, S3 get object, to all objects in a bucket. However, the account-level S3 block public access settings are enabled to block public bucket policies. When an anonymous user attempts to access an object, what will be the outcome? Option A. Access will be granted because the bucket policy explicitly allows it. Option B. Access will be denied because S3 block public access settings have the highest precedence for public access. Option C. Access will be denied only if an IAM policy also explicitly denies it. Option D. Access will be granted, but the request will be logged as a security alert. The correct answer is, quote, access will be denied because S3 block public access settings have the highest precedence for public access. Here's the explanation. S3 block public access settings are the first line of defense and have the highest priority for public access. If an account level or bucket level S3 block public access setting prevents the requested access, the request is immediately denied, regardless of any other policies. Question 5. An AWS account, account A, needs to grant read-only access to a specific S3 bucket to another AWS account, account B. Which is the most appropriate and recommended mechanism for account A to grant this cross-account access? Option A. Account A should create an IAM user for account B and provide them with credentials. Option B. Account A should use an S3 access control list, ACL, on the bucket to grant read access to account B's canonical user ID. Option C. Account A should attach a bucket policy to its S3 bucket, specifying account B's AWS account ID as the principal and granting S3 get object. Option D. Account A should create a pre-signed URL for each object account B needs to access. The correct answer is account A should attach a bucket policy to its S3 bucket, specifying account B's AWS account ID as the principal and granting S3 get object. Here's the explanation. S3 bucket policies are the primary mechanism for granting permissions to other AWS accounts for specific S3 resources. This allows account A, the resource owner, to define what account B, the principal, can do. Account B would then use an IAM policy in its own account to allow its users/roles to assume those permissions. Question 6. Which S3 security feature, when enabled, simplifies permissions management by disabling all bucket and object ACLs and ensuring that the bucket owner automatically owns all objects written to the bucket? Option A. S3 block public access. Option B. IAM identity-based policies. Option C. S3 object ownership with bucket owner enforced setting. Option D. S3 versioning. The correct answer is S3 object ownership with bucket owner enforced setting. Here's the explanation. The bucket owner enforced setting for S3 object ownership is a modern simplification that disables all bucket and object ACLs. This centralizes access control exclusively through IAM policies and S3 bucket policies, making permissions management much simpler and more predictable by eliminating ACL complexities. Question 7. What is a fundamental characteristic of Amazon EBS volumes? Option A. They are ephemeral storage, with data being lost when the EC2 instance is stopped or terminated. Option B. They are object storage, accessed via API, and suitable for unstructured data. Option C. They provide persistent, network-attached, block-level storage for EC2 instances. Option D. They are shared file system storage, mountable by multiple EC2 instances across different availability zones. The correct answer is they provide persistent, network-attached, block-level storage for EC2 instances. Here's the explanation. Amazon EBS is a high-performance, block-level storage service designed for use with Amazon EC2 instances. It provides persistent block storage volumes that are network-attached, meaning data remains intact even if the associated EC2 instance is stopped, terminated, or fails. Question 8. Which EBS volume type is specifically designed for I/O-intensive, mission-critical applications requiring sustained high performance and low latency, such as large relational or NoSQL databases? Option A. General Purpose SSD GP3. Option B. Throughput Optimized HDD Street 1. Option C. Provisioned IOPS SSD IO2 Block Express. Option D. Cold HDD SC1. The correct answer is Provisioned IOPS SSD IO2 Block Express. Here's the explanation. Provisioned IOPS SSD IO1 IO2 Block Express. Volumes are designed for IO-intensive, mission-critical applications that require sustained high performance and low latency, such as large relational or NoSQL databases. IO2 Block Express offers the highest performance and durability among these types. Question 9. A solutions architect needs to create a point-in-time backup of an EBS volume and store it durably. This backup should also be used to create new EBS volumes or copy data across AWS regions. Which EBS feature should be utilized? Option A, EBS multi-attach. Option B, EBS snapshots. Option C, EBS elasticity. Option D, EBS fast snapshot restore, FSR. The correct answer is EBS snapshots. Here's the explanation. EBS snapshots are point-in-time backups of EBS volumes. They are incremental, stored durably in Amazon S3, and can be used to restore new EBS volumes, copy data across AWS regions, or share data with other AWS accounts. Thanks for watching. Please subscribe to my channel.